All right, so I'm going to do some problems that I put on Blackboard. So we'll do the solutions. So if you go and do test one material, and of course, this is all the homework, 4 homeworks per chapter. Well, 4 homeworks including a quiz. There are 4 things. All right, so you're going to come down here to where it says video and examples. Open up that folder. And so the first thing I want to bring your attention to is this test one formulas, which I already have open. I just downloaded it. So this is what it looks like. This is one of the formulas for chapter 1 is what's the angle of the noon sun at a particular latitude. Of course, noon is when the sun gets highest in the sky. So on the summer solstice, which is right around June 21st, depending on what your latitude is on the Earth, you use this formula, and we're about to use this formula as well. On the winter solstice, notice it's the same for all of them. It's the same. 90 minus your latitude. 90 minus your latitude. So in the wintertime, it's minus 23.5 degrees. In the summertime, it's plus 23.5 degrees. That's the tilt of the Earth. Notice in the fall and the spring, it's just 90 minus your latitude. There's an equal amount of day and nighttime. All right, so there's some other formulas in here. We'll get to this stuff a little bit later. There's Kepler's third law, for example. This is the angular size of things. We'll get to that. The velocity is distance divided by time. All right, so this is all the stuff that you need for test 1. All right, so a lot of this stuff down here is all chapter 3 stuff, so you wouldn't have seen that yet. All right, so let's get to the formula. All right, so I've got here's our first problem. All right, and I just did these in order. So it says Pendleton. Okay, so that's where the main campus is at a latitude of 34.7 degrees. What is the altitude of the noon sun on the first day of summer? It should really say the first day of summer and the first day of winter. Well, it does say that actually on the summer solstice and the winter solstice. Okay, which is one day of the year. Those formulas, that's exactly what those are for. It's either the solstices or the equinoxes. Of course, we can tell what the angle is of the noon sun in between. It's highest in the sky on the solstices or lowest in the sky on the solstices. So it's somewhere in between that, but it uses trigonometry functions, which is not really part of this class. So we're not gonna do that. All right, so let's work this out. It's fairly simple. So for the first day of summer, all right, for summer, all right, summer. So for summer, so the angle of the sun at noon when it reaches the highest point in the sky is going to be 90 degrees minus the latitude of Pendleton. That's supposed to be a degree symbol. Minus the latitude of Pendleton, which is 34.7. And then we say, since it's summer, it's plus 23.5. All right. I mean, this is really simple. These are already in degrees, and you just add that up. For the winter time, I'll do the calculation in just a second. Winter. In winter time, it's of course 90. I'm gonna avoid the degrees. All right, so minus 34.7 minus 23.5. All right, so there's your calculation. Let me get my handy calculator, which I really don't like, but it serves its purpose. All right, so here we go. 90 minus 34.7. All right, so there it is, and then we're going to add 23.5, so plus 23.5 because that's the the tilt of the Earth. So the first answer is 78.8 degrees. And if you think about that, 90 degrees would be straight overhead. And so this is actually pretty high in the sky. If you kind of just reflect on that for a moment. All right, let's do the other one. The other one, of course, would be, that 53 point. So the first part I don't have to do again because I already know that it's 55.3. All right, so 55.3, but then minus 23.5. All right, so that's so now it's 31. So on the first day of winter, it's going to be as low in the sky as it's ever going to get, 31.8 degrees. All right, so that's our first problem. Here's problem number 2. This is just a conversion between arc seconds and arc minutes, and arc seconds and degrees. All right, so we have some angle. All right, so this is the idea. We have some angle. Let's say the angular diameter of something. I'm just going to use theta as my angle. Usually we use Greek letters. Is 1,896. And remember, 2 hash marks means arc seconds. All right, so we want to convert that into, as it says here, into arc minutes and then into degrees. All right, so really there's 2 problems here. So theta is equal to how many arc minutes. All right, so I'm going to write down the number of arc seconds. So it's 1,896 arc seconds. And so what I do is I say, all right, well, I'm going to use this conversion right here. So I know that there are 60 arc seconds. 60 arc seconds. You could either write the 2 hash marks or you could write the arc sec. That's fine. In 1 arc minute. All right. So essentially this and this cancel. The units cancel. So it's just, let me get my calculator real quickly. So it's just, let's clear this last problem. It's simply this angle, 1,896 arc seconds divided by 60 will convert it into arc minutes. All right, so it turns out to be 31.6. All right, so this turns out to be 31.6. And again, you can write it like this: arc minutes, or you could write 31.6 with a single hash mark. It means the same thing. All right, let's do the second part. So the second part, theta, is, we started out with 1,896. I'll write it as arc seconds this time. Arc sec. All right, and then we say, all right, well, I know that in 1 arc minute, there are 60 arc seconds. All right, so this cancels this. And then I say, all right, well, in 1 degree, there's 60 arc minutes. So 1 degree, there are 60 arc minutes. All right, and so what goes in the denominator has to cancel what's in the numerator. All right, so we just take this 1,000. I'm going to start it from the beginning here. As soon as I get my calculator, where is it? There it is. All right, so here's our calculator. Let's just start like we're just starting from scratch. So 1,896 divided by 60 squared. All right, so you probably have, so make sure you have a scientific calculator for this class. This is a college level science class, so you should be able to square this. All right, so and then say equals. All right, so and it says, let's see, it should tell us how much to round this. I forgot to include that. Normally these things will say, so for this one, let's round it to 2 places past the decimal. All right, so it's going to be 0.5 something. All right, and so what you do is you look to the third third place past the decimal, it's 6 or higher, so I'm going to round up. So this angle of 1,896 arc seconds turns out to be 0.53. So here, this is what it is, 0.53 degrees. All right, you can use that little symbol, or you can say, 0.53 degrees. That's fine. All right. By the way, when you do the actual part 2 test, it'll ask you what the answer is, and you won't have to put the units. In fact, you don't want to put the units. And I'll mention this again. You just put the number. All right. So you'll just put. It'll tell you, convert it to degrees or convert it to arc seconds, and that's all you do. All right, so let's do the third one. All right, so the third one, let's read this carefully. It says an angle is measured to be 1 degree, 5 arc minutes, and 27 arc seconds. That's the way you read it. That's a single angle. Remember, an arc minute is a fraction of a degree, and an arc second is also fractions of degrees. They're fractions of arc seconds, but they're also fractions of degrees. So one could write this in this way. So theta here. So this is theta. Let's make sure that's correct here. All right. So theta. Now that looks better. So theta is 1 degree. All right. And 5 arc minutes and 27 arc seconds. All right, so another way to write this would be in the following way. 1 degree plus 5 arc seconds plus 27 arc minutes. All right, so what we're going to do is we're going to use the conversions, which I should have written down. Sorry, I forgot. So, of course, 1 degree is 60 arc minutes. And 1 arc minute, so it's comma, 1 arc minute is 60 arc seconds. All right, so now I'm going to convert this and add these things up. I'm going to convert them into degrees. All right, because, for example, this says, what is the angle in degrees? All right, so here is theta. All right, so we'll do the work, and then we'll get our calculator. So it's 1 degree. Well, that's already in degrees. All right, plus 5 arc seconds. Of course, I've got to convert that. I know that there are 60 arc seconds. 5 arc minutes. There are 60 arc minutes in 1 degree. All right, so the arc minutes cancel. Plus 27 arc seconds, and I know that in there are 60 arc seconds in 1 arc minute, and this is we're gonna end up dividing by 60 squared. There are 60 arc minutes in 1 degree. All right, so that's what this turns out to be. All right, I'm gonna rewrite it. It's gonna look like this: 1 plus, and this is all gonna be in degrees. 5 divided by 60 plus, oops, that's a 60, sorry, plus 27 divided by 60 squared. All right, so that's it. That's literally what you do. All right, so let me do this in my calculator. So we got 1, you can just do it straight across. 1 plus 5 divided by 60 plus, because they're fractions, it'll do this in the correct order. 27 divided by 60 squared. All right, so this is going to give us, and then I hit equals. And so if I rounded this to 2 places past the decimal, it would be an angle. I mean, you see, it's slightly greater than 1 degree. All right, so it's 1.09. So 2 places past the decimal, that would be 1.09 degrees. All right, so 1.09 degrees. All right, that's the last one That's chapter 1 stuff. So make sure you can do this.